Welcome everyone to today's class. Uh, the topic we have today is the nature of solution, or what we call root of solution of a quadratic equation. So it is very simple topic, okay? So we are going to look at what kind of root can a quadratic equation have. So we are going to start off with the nature of the roots. Number one, real and distinct roots. Real and distinct what? Roots. We know that a quadratic equation always have two solutions because of the having a s square, because of the presence of s square, we always expect it to have two solutions. So real and distinct roots, this is a situation that the roots of a quadratic equation are real numbers, but of different values. So it's going to give you a real number and different value. Then we say that that particular quadratic equation has a real and distinct roots. So what does that mean? That is s equals to x1 or s equals to x2. So these are the roots of the equation. So anytime you solve a quadratic equation and you have two different numbers that are real numbers, it simply means that the kind of solution that particular quadratic equation has is a real and distinct root. Okay, so we can actually find these real and distinct roots, or find the nature of a particular uh, quadratic equation without solving the quadratic equation. So how can we do that? If b squared minus 4ac is greater than 0. So we say that a quadratic equation is going to give us a real and distinct root if b minus ac is greater than 0. We know that our general form of a quadratic equation is as squared plus bs plus c equal to 0, such that a not equal to 0. So if you bring your a b c and you now insert it here and you get a number that is greater than 0, it simply means that that quadratic equation is real, and what that quadratic equation has a real and distinct root. Okay, now we can actually see that also when you plot your quadratic graph. So when you have a graph of this nature, when you have a graph of this nature, whether it's like this or is like this. So whenever you have a quadratic of this nature that gives you this kind of graph, it simply means that that quadratic equation is real and what? Distinct roots. Remember, the x1 or x2 can be interchanged. So when you plot your graph, and this is the kind of graph you have of a quadratic equation, the roots are real and distinct. So let us look at the second type of solution that we can get when solving quadratic equation. Number two, real and equal roots. Real and equal roots. So this is a situation that the root of a quadratic equation are real numbers and of the same values. And of the same values, that is x equals to x1, which is also equal to what? S2. So here you can see that S1 and S2 are the same. So in such case, we say that it is a real and equal root. Okay. Now, when do we get that? We get that if b square minus 4ac equal to 0. So anytime we test our quadratic equation and we have that b square minus 4ac equal to 0, we say that it is a real and equal root. Now, when you plot your graph, what kind of graph will you get and know that yes, this is a real and equal root? If your graph is of this nature, or of this nature, you will notice that the curve touch the s-axis only at one point. The curve touch the s-axis only at one point. So in such case, we say that it is real and equal root. So those quadratic equation that you will solve and get two numbers that are the same as the root of the equation, then though they belongs to real and what? Equal root. Now let us look at the last one, which we don't talk much about at secondary school level, but we are going to just talk about it a little here. Okay. Okay. The third one is no root. At secondary school level, we say that it has no root. Though, when you move a little bit advanced, we call it a complex root. This is because the root that we obtain while solving that particular quadratic equation is not going to give us a real number. So since it's not going to give us a real number, we say it has no real root. But that does not mean that there's no root. It simply means that it has what? A complex root. And what is complex root? Root means that the root of the equation is a complex number. Complex number is a combination of real numbers and imaginary number. So how does it look like? So this is a situation that the quadratic equation has no real root. That is, has no real number as its root. So this is a situation that the quadratic equation has no real root. So it means that the root of the equation uh, does not lie on the real line. So it does not have any real number as its root. Rather, it has a imaginary number and a real number, which makes it a complex root. So The When do we know that, okay, this quadratic equation is actually going to give us a complex root or it has no real roots? That is if b square minus 4ac is less than 0. So when b square minus 4ac is less than 0. So whenever you test your quadratic equation using your ABC, you put it here and you get a value that is less than 0, it simply means that that quadratic equation has no roots, okay? Or rather, has no real roots. So when you plot your graph, when do you notice that from your graph that a quadratic equation will not have any roots? That is when your graph looks like this, okay, or when your graph looks like this. So one thing you will notice here is that the graph is not touching the x-axis, which is the real line, and the curve here is also not touching the x-axis, which is the real line. So whenever you have your curve of this nature and is not touching the real line, that particular quadratic equation has no roots, or we say it has a complex root. So we can solve few examples to just play around with this, because it's something that you can just play around with. Okay, it's a very simple topic. So let us see some of the examples or some questions that you can be asked on this particular topic. So the first question we are going to look at is 2s squared minus 3s plus 4 equal to 0. So we want to find the nature of solution. We want to know whether it's going to give us a real root, it's going to give us a distinct root, it's going to give us a complex root. So we just want to know. So what do? We first of all list out our value of a, which is 2, b, which is minus 3, and c, which is 4. We test it with our b square minus 4ac and see the kind of number we get. So let's try it here. Minus 3 all square, which is our b square, minus 4 into a is 2 and c is 4. So what would that give us? This will give us 9. 4 times 4 times 2 give us minus 32. So 9 minus 32 will give us minus 23. Okay. 9 minus 32 will give us minus 23, which is less than 0. Therefore, the equation will give a complex root. So you can see how easy it is. You just test it with your b square minus 4ac and find out whether it's less than 0, whether equal to 0, whether it's greater than 0. So let us solve another question. 4s squared minus 9s minus 1 equal to 0. So what are we testing it with? We are testing with b squared minus 4ac. So let's first of all list out our coefficients. A equals to 4, b equals to minus 9, and c equals to minus 1. B squared minus 4ac will give us minus 9 squared minus 4 into 4 into minus 1. So that will give us 81. This will give us minus will give us plus 16. So that will give us 97, which is greater than 1. Therefore, the equation will give a real and distinct root. So that's how we play around that. That's a very simple topic. So let's summarize the lesson, or let's write out something that you can just take, and understand it and follow it anytime you want to solve for nature of solution of a quadratic equation. So in summary, if b square minus 4ac is greater than 0, that's real and distinct roots. That's number one. Number two, if b square minus 4ac equal to 0, that's real and equal root. Then number three, if b square minus 4ac is less than 0, that is no real root, or what you say is a complex root. Okay, so that's where we are going to end today's class. Please, if you are watching this, I want to encourage you to subscribe to the channel so that you see more of lessons like this. Thank you very much and see you in the next video.